So now we are on chapter number 12, which is for loops. In the previous chapter, we mentioned that sometimes you'll want to use a for loop to build the contents of an array in a function rather than simply saving that array storage. Let's look at why. For our get zombie owner function, name implementation would be to store a mapping of owners to zombie armies in a zombie function contract. Yeah, it is owner zombie. And every time we created a new zombie, we would simply use owner to zombie owner dot push zombie to add it to the owner zombies array, and get zombie owner would be a very straightforward function. Here it is. The problem with this approach is the approach is tempting for its simplicity, but let's look at what happens if we later add a function transfer zombie from one owner to another, which we'll definitely want to add in the later lessons. Let the transfer function would need to push the zombie to the new owner to zombie array, remove the zombie from old owner to zombie array, shift every zombie in the older owner's array up one place to fill the hole, and then reduce the array length by 1. Step 3 will be extremely expensive case-wise, since we have to write for every zombies whose position we shifted. If an owner has 20 zombies and trades away the first one, we would have to do 19 writes to maintain the order of the array. Since writing the storage is one of the most expensive operations in Solidity, every call to this transfer function would be extremely expensive cache-wise, and worse, it would cost a different amount of cache each time it's called, depending on how many zombies the user has in their army and the index of the zombie being traded, so the user wouldn't know how much cache to send. Of course, we could just move the last zombie in the array to fill the missing slot and reduce the array length by 1, but then we would change the ordering of our zombie army every time we made a trade. Since view function don't cost cache when called externally, we can simply use a for loop in get zombie by owner to iterate the entire zombie array and build an array of the zombies that belongs to the specific owner. Then our transfer function will be much cheaper since we don't need to record any array in storage, and somewhat intuitively this approach is cheaper overall. Okay. Using for loops. The syntax for loops in Solidity is similar to JavaScript. Let's look an example where we want to make an array of even numbers. Here it is. Here is a for loop and a checking condition and array to array if it's even. The function will return an array with the content 2, 4, 6, 8, 10. Here it is. So now let's put it to test. Let's finish our get zombie by owner function by writing a for loop that iterates through all zombies in our TF, compares their owner to see if we have a match, and pushes them to our result array before returning it. Declaring a uint called counter and set it equal to 0. We'll use the variable to keep the track of the index in our result. Okay, now let's see. Uint counter and set it to 0. Declare for loop that starts from uint 0 and goes through the zombie.length. This will iterate over a zombie in our array. So let's create a for loop uint I equal to 0, I is less than zombies dot length I plus plus. Okay. Inside the for loop, make an if statement that checks zombie owner is equal to owner. If zombie to owner I equal to underscore owner, this will compare two address to see if we have a match. Same if statement add the zombie ID to our result array by setting result counter equal to I. Okay. Result counter equal to I. Okay. Increment counter by 1. Counter plus plus. Excuse me. That's it. The function will now return all the zombie owned by owner without spending any gas. Okay. So now let's check the answer. Okay, that's correct. So we have completed chapter number 12. Now let's move on to chapter number 13.